Hi friends, today's video is about finding the units digit of large expressions like the ones you can see on your screen. This is a very popular topic in all competitive exams, and this single video will help you ace this maths concept and score full marks in this topic. So this is the complete list of all the questions we are going to discuss in this video, and they might look scary to you at first, but believe me, by the end of this video, you will be able to solve all of them with confidence. Just keep a paper and pen ready to take down the notes, and let's begin. So let us suppose we have to find the units digit of 53 into 72. We already know that in our decimal system of numbers, the last digit of a number is called the units digit. The second last is called the tens digit. The third last is called the hundreds digit, and so on. When we multiply 53 and 72, and this is how we do it, pay attention. We first multiply 2, the units digit of 72, with the units digit of 53 and jot down the product of these two digits, which is 6. And later, we multiply it with the rest of the number. Once we are done with 2, the units digit, we move on to the next line and put a cross here before multiplying 53 with 7, which is the tens digit. The point is, when you add these two lines to find out the product, at the units place, we will simply copy this number, 6, which we got by multiplying the last digits of these two numbers. So the idea is very simple. When we talk about the units digit of a product of numbers, only their units digits matter, and we can safely ignore the rest of the digits in those numbers. Same holds true for addition or subtraction. If we have to find the units digit of 153 plus 2376 minus 207, while solving this sum, we will align the units digit of all the three numbers like this. And therefore, the units digit of our answer will depend only and only on the units digit of these three numbers. Now, the maximum application of this concept of units digit is when we have numbers with powers. So let's say we have to calculate 83 square. We know it is 83 into 83. When we calculated 53 into 72, we learned that the units digit of a product depends only on the units digits of the numbers involved. That's why we can safely ignore the tens digit 8 and simply calculate 3 square. 3 into 3 is 9. Therefore, the units digit of 83 square will be the same as that of 3 square, which is 9. In the next example, we have to find the remainder when 47 cube is divided by 10. You might be wondering what's a remainders question doing in the concept of units digit. But hang on, you will soon understand. So someone who is doing this question for the first time will likely calculate 47 cube. 47 into 47 into 47. 47 square is 2209. That into 47 is 103823. This when divided by 10, the remainder will be nothing else but the units digit. Did you realize this question is just a different way of asking the units digit of 47 cube, because any number when divided by 10 leaves the units digit as remainder. We know the better way of doing this was just multiplying the units digit of 47 with itself 3 times. 7 into 7 into 7 is 7 sevens are 49 and 9 sevens are 63. The units digit has to be 3. And you will save a lot of time by doing this question like this. Time management is a very important aspect in all entrance exams. So the questions we have done so far teach us a very important tip, and that is to find the units digit of an expression when we add, subtract, multiply, only the units digits of the numbers matter. Let's apply what we have learned so far to the question on your screen. Find the units digit of 71 into 72 into 73 up to 79. Units digit only depends on the units digit of the numbers involved. So when we multiply the first three numbers, 1 into 2 into 3 gives us 6 as the units digit of these three numbers. Multiplying 6 with the units digit of the fourth number gives us 6 into 4, 24. That is 4 as the units digit of first four numbers. Now 4 multiplied with the units digit of the fifth number, which is 5, gives us 20. Therefore, the units digit of the first 5 numbers multiplied together is 0. Can you guess what will happen next? Since 0 multiplied with anything else is also 0, 0 into 6 into 7 into 8 into 9 is also 0. So our answer for the units digit of this expression is 0. There is a very important takeaway in this question. 5 multiplied with any even digit results in 0. There are many more questions based on this, and if you have a slight hint, it helps you solve such questions easily with confidence, isn't it? Let's move on to our next question. If you add up the first 55 whole numbers, what will be the units digit of the sum? Now, whole numbers are all numbers starting 0, which you can count on your fingertips. Natural numbers start from 1. Sum of first 55 whole numbers will be equal to the sum of first 54 natural numbers. Now, obviously, you won't add these numbers one by one. We will use the formula. We know that the sum of first n natural numbers is n into n plus 1 by 2. There is a very interesting story behind this formula which you can learn through our video on the same topic. So sum of first 54 natural numbers is 54 into 54 plus 1 by 2. This simplifies to 27 into 55. The units digit will be same as that of 7 into 5. 7 5s are 35. So our answer for this question is 5. Now with this basic background, let's start the most important and tricky part of this chapter. Finding the units digit of a number raised to a power. Say x raised by y. When we have numbers like these, x is called the base and y is called the power, index or exponent. We know that the number in the base has to end with one of the digits from 0 to 9. Or in other words, the units digit will vary from 0 to 9, right? These 10 digits from 0 to 9 can further be divided into 3 categories, out of which the simplest category is number ending in 0 or 1 or 5 or 6. Why so? Because you may raise these numbers to an arbitrary power, but their units digit will remain the same. For example, take 10. 10 raised by 1 ends with 0. So does 10 raised by 2. Ditto for 10 raised by 3 and so on. The zeros keep on increasing. If the number has a units digit of 0, no matter what power it is raised to, it will always end in 0. Same is the case for numbers with units digit 1. 1 into 1 is always 1. So, if the given number has a units digit of 1, no matter what power it is raised to, it will always end in 1. Again, 5 into 5 is 25, which also ends with 5. That means, if the given number has a units digit of 5, it will always end in 5, no matter what power it is raised to. And the last digit in this category is 6. 6 into 6 is 36. So a number with a units digit of 6 will always end in 6, regardless of its power or exponent. Simple so far, right? Let's apply what we have learned to the following question. Find the units digit of 21 raised by 201 minus 35 raised by 305 plus 46 raised by 406. So we know that the units digit remains the same in the case of 0, 1, 5 or 6. Our answer will be 1 minus 5 plus 6, which is 2. Our answer for this long expression will be 2. Category 2 is when units digit of the base is 4 or 9. Let's look at powers of 4 to get an idea of how these questions are to be attempted. 4 raised power 1 is 4. 4 raised power 2, 16. 4 raised power 3, 64. 4 raised power 4, 256. 4 raised power 5, 1024, and so on. Look at the units digit of these powers to see how they behave. 4, 6, 4, 6, 4. There is an alternating pattern of 4 and 6. Whenever the power of 4 is odd, the units digit is 4, and whenever it is even, the units digit is 6. And indeed, if I need to find out the units digit of 4 raised power 6, I just need to multiply the units digit of 4 raised power 5, which is equal to 1024 with 4. 4 multiplied by 4 is 16. So next units digit will be 6. And 6 multiplied by 4 is 24. So the units digit of the number after that, which is 4 raised power 7, will again be 4. So we say that the powers of 4 have a cyclicity of 2. 4 raised power 1 or 4 raised power any odd number ends in 4. Whereas 4 raised power 2 or 4 raised power any even number ends in a 6. For example, if we have to find out the units digit of 74 raised power 1536, how do we go about solving this question? First of all, just keep the units digit of the base, which is 4, and ignore all other digits before that. So essentially, we have to find out the units digit of 4 raised power 1536. And since 4 raised power any even number ends in 6, our answer is 6. Similar pattern is observed in powers of 9. 9 raised power 1 is 9. 9 raised power 2, 81. 9 raised power 3, 729. 9 raised power 4, 6561, and so on. 9 raised power 5 will have a units digit of 1 into 9, that is 9. And 9 raised power 6 will again have a units digit which is same as that of 9 into 9, 81, which ends in 1. 919191 is the alternating pattern for the units digit of 9. Again, two different possibilities for units digit, so cyclicity is 2. So just remember that 9 raised power 1 and also any odd power of 9 will have a units digit of 9, whereas 9 raised power 2 or any even power of 9 will have a units digit of 1. Let's try out a question. What's the units digit of 139 raised power of 237? So first of all, we ignore all other digits in the base except the units digit. That means we have to find out the units digit of 9 raised power of 237. And 9 raised power of any odd number has a units digit which is same as that of 9 raised power of 1, that is 9. So our answer is 9. And the last category, category number 3, is when the units digit of the base is 2, 3, 7 or 8. Let's discuss the base 2. Looking at its powers, 2 raised power 1 is 2, 2 raised power 2, 4, 2 raised power 3, 8, 2 raised power 4, 16, and 2 raised power 5 is 32. There is again a recurring pattern, isn't it? Units digits are 2, 4, 8, 6 and again 2. Next is 2 raised power 6. Units digit will be 2 raised power 2, that is 4. For 2 raised power 7, units digit will be 4 into 2, that is 8. For 2 raised power 8, units digit will be same as that of 8 into 2, that is 16. So we keep 6 since we are interested only in the units digit. For 2 raised power 9, units digit will be same as that of 6 into 2, that is 12. So we keep 2. So units digit are repeating themselves in a pattern of 4. The cyclicity is 4. 2486, 2486 and so on. So for powers of 2, just remember that there are 4 steps in the cycle. Add At the first step, the units digit will be same as that of 2 raised power 1, which is 2. At the second step, the units digit will be same as that of 2 raised power 2, which is 4. At the third step, the units digit will be same as that of 2 raised power 3, which is 8. And at the fourth step, the units digit will be same as that of 2 raised power 4, which is 6. So pay attention. The fourth step of this cycle is when you have 2 raised power 4 or 2 raised power 8 or 2 raised power 12 or 2 raised power 16 or 2 raised power 20 and so on. When powers are multiples of 4, we are at the fourth step of the cycle when the units digit will be 6. Next important question is, how do we find out which step of the cycle a given power lies? Yeah. So let's try out a question to understand this challenge. What's the units digit of 52 raised power 43? Just ignore the 5 in the base and keep only 2. Find the units digit of 2 raised power 43. Which step of the cycle would this be? Okay, so if the power were 40, a multiple of 4, that would be at the fourth step, right? 43 minus 40 is 3. So the power of 43 means we are at the third step of the cycle. Units digit will be the same as that of 2 raised power of 3. That is, it will be 8. Our answer is 8. So what exactly do we need to do? We must extract the maximum multiple of 4 from the given power, which means we must divide the power given in the question by 4 and find out the remainder. If the remainder is 0, that means the given power is a multiple of 4 and we are at the fourth step of the cycle. Else, if the remainder is 1, 2 or 3, then we are at the same step of the cycle as the remainder we obtained. Like in this case, the power was 43. 43 divided by 4, the remainder was 3. So we were at the third step of the cycle. Next question is to find the units digit of 192 raised power of 284. Just keep 2 in the base and ignore the digits before that. 2 raised power 284. Now 284 when divided by 4, and you can use the divisibility rule of 4, which means just divide the last 2 digits by 4 and see. So 84, it turns out, is the multiple of 4. The remainder is 0. We are at the fourth step of the cycle. So units digit will be same as that of 2 raised power 4. 16. So our answer is simply 6. And the last practice question for base 2 is to find the units digit of 2022 raised power of 2021. Ignore these digits in base. Power is 2021. Which step of the cycle? Divide 2021 by 4. 21 divided by 4, remainder is 1. So we are at the first step of the cycle. And units digit will be the same as that of 2 raised power 1, which is 2. Our answer is 2. Let's move on to base 3. Looking at its powers, 3 raised power 1 is 3. 3 raised power 2, 9. 3 raised power 3, 27. 3 raised power 4, 81. 3 raised power 5 is 243. And so on. There is a cyclicity of 4. Units digits are repeating in a pattern of 3971 and again 3971, and this pattern continues for higher powers of 3 as well. So for powers of 3, the 4 steps in the cycle would be, at the first step, the units digit will be the same as that of 3 raised power 1, which is 3. At the second step, the units digit will be the same as that of 3 raised power 2, which is 9. At the third step, the units digit will be the same as that of 3 raised power 3, which is 7. And at the fourth step, the units digit will be the same as that of 3 raised power 4, which is 1. And just remember, the fourth step of this cycle is when the power is a multiple of 4, when it is exactly divisible by 4. Let's try out some questions now. Find the units digit of 3 raised power of 100. The power 100 is clearly divisible by 4. So we are at the fourth step of the cycle. Units digit will be the same as that of 3 raised power 4, which is 81. So our answer is 1. Next we have to find the units digit of 263 raised power of 262. In the base, just keep the units digit 3 and ignore the digits before that. So what's the units digit of 3 raised power 262? Divide the power by 4 to see which step of the cycle you are at. Now 262 when divided by 4, it leaves the remainder 2. So that means we are at the second step of the cycle. So units digit will be same as that of 3 raised power 2. So our answer is 9. Next question is a little different. Find the units digit of 3 raised power 75 minus 3 raised power 57. So we just try to find the respective units digit of these two numbers. 3 raised power 75, 3 raised power 75. 75 when divided by 4 leaves the remainder 3. Third step of the cycle. So units digit will be same as that of 3 raised power 3, which is 27. So we jot down 7. 3 raised power 57. The power 57 when divided by 4 leaves the remainder 1. First step of the cycle. So units digit will be same as that of 3 raised power 1. We jot down 3. Our answer is simply 7 minus 3, that is 4. Units digit of this expression is 4. Then we have base 7. Looking at its powers, 7 raised power 1 is 7. 7 raised power 2 is 49. 7 raised power 3 is 343. 7 raised power 4 is 2401. For 7 raised power 5, units digit will be 1 into 7. So units digits have started repeating in a cyclicity of 4. They are repeating in a pattern of 7931 and again 7931, and this pattern will continue for higher powers of 7 as well. For powers of 7, the 4 steps in the cycle would be: at the first step, the units digit will be same as that of 7 raised power 1, which is 7. At the second step, the units digit will be same as that of 7 raised power 2, which is 49, so 9. At the third step, the units digit will be same as that of 7 raised power 3, which is the same as that of 9 into 7, so 3. And at the fourth step, the units digit will be same as that of 7 raised power 4, which is the same as that of 3 into 7, so 1. And again, we must remember that the fourth step of this cycle is when the power is a multiple of 4 and is exactly divisible by 4. Let's try out some questions now. Find the units digit of 37 raised power 40. First, ignore 3 in the base. Next, the power 40 is clearly divisible by 4. So we are at the fourth step of the cycle. Units digit will be the same as that of 7 raised power 4, which is 1. So our answer is 1. Next, we have to find the units digit of 387 raised power of 387. Now don't get confused if the base and power are the same. Our procedure to solve this question doesn't change because of that. In the base, just keep the units digit 7 and ignore the digits before that. So what's the units digit of 7 raised power 387? Divide the power by 4 to see which step of the cycle you are at. Now 387 when divided by 4 leaves the remainder 3. We are at the third step of the cycle. So units digit will be same as that of 7 raised power 3. So our answer is 3. In the next question, we have to find the units digit of 57 raised power 75 plus 37 raised by 73. Again, ignore the extra digits in the bases of these two numbers and just keep their unit digit, which is 7 for both. 7 raised by 75. 75 when divided by 4 leaves the remainder 3. Third step of the cycle. So unit digit will be same as that of 7 raised by 3, which is 3. 7 raised by 73. The power 73 when divided by 4 leaves the remainder 1. First step of the cycle. So unit digit will be same as that of 7 raised by 1. We jot down 7. Our answer is simply 3 plus 7, which is equal to 10. And the last digit of 10 is 0. So our answer for the unit digit of this expression is also 0. And finally, the base of 8. Looking at its powers, 8 raised by 1 is 8. 8 raised by 2 is 64. 8 raised by 3 is 512. For 8 raised by 4, unit digit will be 2 into 8, which is 16. So we write 6. For 8 raised by 5, unit digit will be 6 into 8, which is 48. So we write 8. Are you able to see that the unit digits have started repeating and there is a cyclicity of 4? The unit digits of the powers of 8 are repeating in a pattern of 8426 and again 8426, and this pattern will continue for higher powers of 8 as well. For powers of 8, the 4 steps in the cycle would be: at the first step, the unit digit will be same as that of 8 raised by 1, which is 8 obviously. At the second step, the unit digit will be same as that of 8 raised by 2, which is 64, so 4. At the third step, the unit digit will be same as that of 8 raised by 3, which is the same as that of 4 into 8. The unit digit is 2. And at the fourth step, the unit digit will be same as that of 8 raised by 4, which is the same as that of 2 into 8. So it will be 6. A reminder, the fourth step of this cycle is when the power is a multiple of 4 and is exactly divisible by 4. Let's try out practice questions specific to base 8. Find the unit digit of 18 raised by 18. First, ignore 1 in the base. Next, the power 18 when divided by 4 leaves the remainder 2. So we are at the second step of the cycle. Unit digit will be the same as that of 8 raised by 2, which is 4. So our answer is 4. Next, we have to find the unit digit of 488 raised by of 273. In the base, just keep the unit digit 8 and ignore the digits before that. So what's the unit digit of 8 raised by 273? Next, divide the power by 4 to see which step of the cycle you are at. 273 when divided by 4 leaves the remainder 1. We are at the first step of the cycle. So unit digit will be same as that of 8 raised by 1. So our answer is 8. And finally, we have a unique question where we have power of a power. Find unit digit of 8 raised by 8 raised by 8. Wow. Focus on its power, which is 8 raised by 8 and divided by 4. Since 8 is divisible by 4, 8 raised by 8 will also be exactly divisible by 4, isn't it? That means we are at the fourth step of the cycle and our unit digit will be same as that of 8 raised by 4, which is 6. So our answer for the unit digit of this expression is 6. Now let's mix up all the three categories and whatever else we have learned so far, and let's try out some awesome questions from this topic. So the question on your screen is, if x is equal to 527 raised power of 725 plus 984 raised power of 367 minus 283 raised power of 823, find the unit digit of x. A quick look at this expression tells us that 7, 4 and 3 are the unit digits of these numbers. So we can just ignore the rest of the digits and reduce the clutter. That will free up our mind. So the reduced bases are 7, 4 and 3. 7 and 3 have a cyclicity of 4, whereas the base 4 has a cyclicity of 2. 4 raised power of an odd number gives us 4 as a unit digit of the middle term. For the terms containing 7 and 3, we will need to know which step of the cycle we are at. So we divide the powers by 4. 725 divided by 4 gives us 1 as remainder. So the unit digit of 7 raised power 725 is same as that of 7 raised power of 1. And 823 divided by 4 gives us 3 as remainder. The unit digit of this term will be same as that of 3 raised power 3. So our unit digit of the expression will be 7 plus 4 minus 7. The result is 4. Next, we have to find the unit digit of 34 raised power of 10 factorial into 33 raised power of 9 factorial into 32 raised power of 8 factorial. You may pause the video if you want to do this question at your own pace. Let's discuss. First step is to reduce the clutter and drop the 10th digit, which is 3 for all these numbers. Now we look at the powers. If you want a quick overview of factorials, you may watch our lesson on that topic. It's a 10-minute lesson which will give you a good enough introduction and practice of factorials. For now, we just need to know that n factorial is all natural numbers from 1 to n multiplied together. Clearly, all powers, that is 10 factorial, 9 factorial and 8 factorial, are even also and divisible by 4 also. Because to evaluate these factorials, we have to first multiply numbers from 1 to 4 and then the further numbers. They are all multiples of 4. So the unit digit of 4 raised power 10 factorial will be the same as that of 4 raised power of any even number, such as 4 raised power of 2. 4 raised power 2 is 16. So we write 6 as its unit digit. Unit digit of 3 raised power 10 factorial will be the same as that of 3 raised power 4, because 10 factorial is a multiple of 4. Since 3 raised power 4 is 81, we write 1 as the unit digit. And 2 raised power 8 factorial, unit digit will be the same as that of 2 raised power 4. 2 raised power 4 being 16, we write 6 again. Multiplying 6 into 1 into 6 is 36, the unit digit of which is 6. So our answer for the unit digit of this expression is also 6. Find the last non-zero digit of 70 raised power of 2021. Again, you might pause the video if you want to try it at your own comfortable pace. And if you have tried, let's discuss. So 70 raised power of 2021, it's clear, will end in a lots of zeros. Do you know exactly how many? Well, 70 is 7 into 10. So 70 raised power 2021 can be written as 7 raised power 2021 into 10 raised power of 2021. All zeros come from 10 raised power of 2021. So 2021 zeros, and more importantly, we have the value of 7 raised power of 2021 written before all these zeros. So if they are asking the last non-zero digit of 70 raised power 2021, that means they are asking the unit digit of 7 raised power of 2021, which we know how to find, isn't it? So 7 raised power 2021, 7 has a cyclicity of 4. So which step of the cycle? For that, divide the power 2021 by 4. We get 1 as remainder. The power lies at the first step of the cycle. So, unit digit of 7 raised power 2021 will be the same as that of 7 raised power 1, which is 7. Our answer is 7. Find the digit in the thousands position of 5 raised power 3 into 2 raised power of 2021. Take your time, pause the video and try out the question. Okay, so if you have tried, let's discuss. So this expression has 3 5s multiplied with 2021 2's. And we know that 5 into 2 is equal to 10. The 3 5's in this expression will combine with 3 2's to add 000 at the end of this number. We can see this happening from the following equation. 5 raised power 3 into 2 raised power of 2021 is equal to 5 raised power 3 into 2 raised power 3 into 2 raised power 2021 minus 3, which is equal to 2 raised power of 2018 into 1000. Clearly, the thousands digit of this expression will be the units digit of 2 raised power of 2018 because we'll have 3 digits 000 written after that. What's the units digit of 2 raised power of 18? The base 2 has a cyclicity of 4 for its powers. So divide 2018 by 4, the remainder will be 2. That means second step of the cycle. Our answer for the units digit will be 2 raised power 2, that is 4. And finally, let's try the last two questions on your screen. At this stage, for these two questions, and only for these two last questions, we see an overlapping between the concept of units digit and the topic remainders. I will try to explain these in the best possible way that I can. But to have a complete understanding of remainders, do watch our next lesson, which will be on remainders. So, find the units digit of 123 raised power 123 whole raised power of 41. Now we know that a raised power m whole raised power of n is equal to a raised power m into n. So 123 raised power of 123 whole raised power of 41 can be written as 123 raised power of 123 into 41. We need the units digit of this number. So just keep 3 and ignore the digits before that. The base 3 has a cyclicity of 4. So we need to know which step of the cycle does our power lie. And the power is 123 into 41. Let's divide it by 4 and find the remainder. The trick for remainder of this is very simple. We don't need to multiply 123 and 41. Just divide 123 and 41 individually by 4 and multiply the respective remainders to find our net remainder. 123 divided by 4 leaves remainder 3 and 41 divided by 4 leaves remainder 1. So our net remainder for 123 into 41 will be 3 into 1, that is 3. That means the power lies at the third step of the cycle. And units digit will be the same as that of 3 raised power 3, which is 27 and ends in 7. Our answer is 7. Next question is, find the units digit of 28 raised power 29 raised power of 30. Ignore the tens digit in the base, which is 2. Now the base is 8. Again, it has a cyclicity of 4. So we need to divide the power by 4 and the power is 29 raised power of 30. Again, for finding remainder, we don't need to calculate the value of 29 raised power of 30. Rather, what we need to do is divide 29 by 4. 29 divided by 4 leaves the remainder 1. So remainder will be 1 raised power of 30, which we know is equal to 1. So the remainder is 1. Hence the power lies at the first step of the cycle. Our answer for units digit will be 8 raised power 1. Our answer is 8. That brings us to the end of this video. I hope the concept of units digit is crystal clear to you now and you can attempt all questions from this topic with full confidence. Do press the like button and share the lesson with your friends as well. We will be glad to take up any queries or doubts that you may have and you can post them in the comments box below. Happy learning and take care.